My name is Nataraj. I go by Nat. I'm a professor at Villanova University and a director research center called VCADS. I'd like to talk about what we call EMeDS or emergency medical delivery systems using technology and primarily unmanned aerial vehicles. And I'm really speaking for an interdisciplinary team of experts, which includes, in addition to me, Dr. Nod Kearney, who is a critical care specialist at Children's Hospital of Philadelphia, Dr. Hari Narayana, who is the is technical expert CEO at General Aeronautics in India, Dr. Ramana Rao, who is the CEO of GVK EMRI, which is one of the largest ambulance services in India, and Dr. Geeta Ramachandra, who works with Dr. Ramana Rao. So our focus is on using unmanned aerial vehicles, and we are focusing on the developing world. In this case, I'm going to showcase India, and I also want to talk about not just the technical problems, but the so many other problems that exist, such as what I would call the infrastructure that needs to be in place for something like this to happen. And we are really talking about many possible applications, but in principle, three of them, which would be the emergency medical response in urban areas, congested areas, and potentially organ transplant support, and also service to rural areas, which are relatively under-resourced. There could be many more applications, which I'll list later on, but also in this talk, I'm going to just focus on the emergency medical response in urban areas where we've had some progress. So this is a typical, those of you who've been to India would recognize this. This is a typical road traffic situation in urban India. Now it is getting better with they're building furiously, but to a large extent this is the case. And a lot of our experience on doing this has been in two cities, Bengaluru in southern India, which is often called the IT capital, and Hyderabad, which are still something like this. So this should give you an idea of the problems that ambulances, for example, would face. So the Indian statistics, which are somewhat suspect and underreported normally, going back to 2000, probably 13 or even earlier than that, is that something like 15 people, including one child, is killed every hour on the road. 60 are seriously injured or disabled every hour, and one person disabled every minute, right? So it's pretty grim, and like I said, it's highly underreported, and it's going up very rapidly as the number of drivers on the road and the number of miles driven has gone up exponentially in recent years with development. So in case of if you think about something that's on the road, what can happen and what can one do, right? So for example, you can have something like a stroke, which is a brain issue. And what could you do on the road? For example, you could do a video diagnosis. You could administer a drug to arrest the problem until the person can be taken to a hospital. You can have a situation like anaphylaxis, which is basically suspension of breath, which is an allergic reaction, for example, right, which disables a person from being able to breathe, and they can die very quickly. What could you do? You could do video coaching. You could give medications such as epinephrine, which will kind of jumpstart, some clear up and get them to start breathing again. Again, these are emergency things that we're doing, kind of holding them till an ambulance can get there, or until they could be taken to a hospital. Of course, you can have myocardial infarction, which affect the heart muscle, and an emergency drug would be able to take care of this. And again, this is not something that would require a doctor to do, right? That's what we're talking about. Now, you could also have a cardiac arrest, which basically, could result in a loss of life. And again, you could do a video coaching. You could do if it is ventricular fibrillation, for example, you could do automated external defibrillators, so-called AEDs. You could do CPR. And then you could have life and limb kind of issues, which is typical in a road traffic accident where you get real physical injury. And that would be, there the priority would be to stop bleeding. So you would need to judiciously and efficiently apply a tourniquet and give medications, for example, or even give blood. And then, of course, the sort of similar problem is organ transplant, where you need an organ transported from point A to point B as quickly as possible, or you would, the patient would die or the organ would degrade. The organ you're trying to transplant would basically be useless. Okay, so these are all sort of the things that can happen on the road, and I'm sure there are more, but these are sort of the top ones. So again, I'm going to focus on India, like I said. In India, lots of people are killed, as I already mentioned. The main reason for death in road accident victims is severe bleeding and results in hypovolemic shock. About 40% of road accident victims die due to excessive bleeding before reaching the hospitals. That's why they die, right? Which is really preventable death. The second thing that can happen, not just on a road, by the way, maybe in a house that's not easily reachable because of traffic, and you can have cardiac arrest, and it has very high mortality, right? It's very low survival rates on the road. The numbers are hard to come by, but it's anywhere from 5 to 10%, right? And for a bystander, somebody who's just watching, to be able to CPR and use the defibrillators is quite rare. You don't see this very commonly, even in the US or the more developed countries, but certainly in India. And the AED availability is poor. It's not really there. It's like it would be in US. You can see them at many different places, and it's kind of common for even in high school to get CPR training. All of this is not that common in countries like India. And so you don't have training, you don't have access, and you have use, and it's poor in the community. And we do know that the bystander resuscitation would improve survival for these patients, and the benefits of chest compression defibrillations are very time sensitive. So, and by the way, this is also true for stroke. What you do in the first 15-20 minutes would improve survival by a factor of 10 or more, right? So it's extremely time sensitive, and the problem is the current emergency response times, like an ambulance getting there, can be very long. I think the median time is something like 28 minutes in Bengaluru, right? So and it can be even longer than that due to traffic, distance, and congestion, communication issues, all kinds of issues like that. So the problem, so the point here is that you want to respond very quickly to improve survival dramatically. The fall off on survival is very survival as well as permanent damage is very rapid. So the first 20 minutes is very critical. So this is the problem, right? So what do you do in the first 20 minutes if there is an accident, there's bleeding, or there's a heart attack? No accident, but let's say there's a heart attack or a stroke or anything like that. So the opportunity to solve this problem, exists, right? So here are sort of the positives. In India, you would call the emergency system by dialing 108. So these call centers are actually have improved dramatically in the last maybe 10 years. They have been highly developed to geolocate, they dispatch ambulances, and they can do coaching by cell phone. The infrastructure for the call centers has been dramatically improved. And then urban India is very dense. So you always have people everywhere. You have tons of police, you have security guards, you have auto rickshaw, the rickshaws that you see, the three-wheeled sort of vehicles that run with scooter or motorcycle engines, right? So these auto rickshaw drivers, little taxis, basically shop owners, There are tiny shops all over the place. There are just carts where they're selling drinks or like soft drinks or ice cream or whatever. They're all over the place. So you will always have people like this who are able to quickly reach the scene. And note also, when we say first responders in a country like US, you may just talk about police or emergency technicians. But in India, we really need to be kind of expand this to include people like rickshaw drivers and shop owners and so on. Okay, and of course, as I already mentioned, simple techniques, very simple techniques would reduce mortality significantly, like phoning the emergency, applying direct pressure, tourniquets, CPR, and so on. So, and again, like I mentioned, it's very time sensitive, and UAVs can equip and facilitate. So here is the point. So why don't we use unmanned air vehicles to equip, to ferry or to get equipment to bystanders as quickly as possible and reduce the time to treatment. So that's the main thing we're looking to do, right? That's the main usage for UAV that we're looking to do, is get to the location of an accident as quickly as possible, and then connect with an appropriate bystander who has been trained to respond quickly and reduce the time to treatment, right? So this is the vision, and let me work through the details now, right? What all the issues are and so on. So we this idea kind of came to us about 3 years ago, and so we applied for a grant to organize a workshop in Bengaluru in India at the Indian Institute of Science. And we called this EMeDS, or Emergency Medical Delivery Systems with Unmanned Aerial Vehicles. And this was done in March 2018, about 2.5 years ago. This was funded by a IUSSTF, which is an Indo-US Technology Forum foundation that funded the workshop. So this workshop had 3 full days of presentations, discussions, and brainstorming. It was co-organized by myself and Dr. Hari Narayana, who's well known in India. He's known as the father of the light combat aircraft system. Like I said, so it kind of comes with good street credibility, if you will. And also a big part of this workshop of the organization was Dr. Nadkarni at Children's Hospital and Dr. Ramana Rao at EMRI, who come with already another system they already have in place, and I'll talk about that. So they've been doing this already, but not using the technology. What we did was we kind of put, and these are doctors, so we kind of, this was an effort to put these two kind of groups of people together. So we invited 65 selected attendees, out of which there were 21 speakers, 6 from the US, 1 from UK, 1 from New Zealand, and 13 from India. And the idea is that this had to cover all different aspects. So we had expertise in engineering, which is obvious kind of things you can think about, like robotics, aerospace, and so on, design, as well as medicine, critical care, telemedicine, organ transplants, and so on, medical infrastructure, because that's very important, with the interfacing with emergency services and ambulances and so on, foundations, so they were represented by American Heart Association, government agencies, because clearly the civil aspects get into the pictures, and we had the US Emergency Care Coordination Center, the head of that, join us, and miscellaneous such as legal and regulatory management, how do you manage this system, police, traffic safety. So we had the head of the police in the Bangalore urban area actually come to this and take part in this workshop and give us his input. So this is sort of a picture of our group that we at the end of the conference at the Indian Institute of Science. So again, I'll tell you a little bit more about this. I'll probably skip all the details just to it's kind of and hopefully this will serve as an inspiration for those of you who are thinking of doing something like this. This was enormously beneficial, the workshop. Okay, and so I think if you want to do something like this would make sense to do something like this, right? That is, you want to kind of do a project like this workshop or something of this sort, I think would be critical to set this off. So we had individual presentations, then we had panel sessions, then finally on the last day we had working groups, and the working groups were divided into four different groups, or three or four different groups, where one is focusing on critical care, another application we discussed was organ transport, and also potentially telehealth. For example, you could, again, I won't talk about this, but if briefly to mention briefly, you could have a UAV with a video that would, for example, fly over and uh, maybe transmit videos, right, and create a two-way video link, for example. And in each objective of each working group was, we talk about what's the need statement, and justify it, and then develop a concept of operations, or what's called ConOps. Then that leads to requirements and specifications, and what are the technology issues, what are the constraints, what are the resources you need, what are the metrics by which you would evaluate the success or failure, or the future of this project, and what is the potential impact you're trying to have, right? So these were, each group was an interdisciplinary group working through all of these details. And that serves as that has served as the document we produce at the end of this has served as a very useful blueprint for how we want to go forward. So one of the outcomes that we came up with that was clear from this was that there are some gaps that UAVs can fix, some gaps that they cannot fix. Okay. So for example, the UAVs can fix the rapid delivery of CPR guidance and so on, improve the fidelity of call taker communication. You can also use UAVs to get a situational awareness, like what's going on. Maybe even recognize the cardiac arrest, for example, or bleeding that's going on, right? And like relay that information by video, for example. Gaps that are not addressed: how about training of people who need to use this? How about public awareness? How about CPR use? How will the people receive the concept of a UAV landing in the midst of this congested area? How do you? See, there are so many issues that kind of go beyond the UAV. Development of a community responder network, which is integrated with emergency dispatch. And what do you do? How does a bystander interact with the drone? What's the logistics of that? And how do you train them? And again, this goes beyond the technology of the typical robotic systems that we normally work on. So, so here are some technical concepts that may be sort of obvious. Again, I'll skip the details of this, but you have to work on the platform, and potentially you could have a coordinated network of drones. And then we decided that vertical takeoff is the most feasible for urban situation. It's got to have reliable navigation, got to have sufficient range, all the things you might think about as what you might call design specs that comes out of this, right? And payload, and then you need sort of instructions for people to use them, consider separate design alternatives. How are you going to interface all these different systems, and then what is the new technology required? Do you need level 4 autonomy, vision technologies? Do you need new vision technologies? Do you want to be able to detect cardiac arrest just from a video? This is urban area. You may have to worry about how do you prevent this from being stolen? How do you prevent this from potentially being hacked into? Right? Which kind of comes with both advanced societies and societies that are developing, right? So both of those problems. And then, power and endurance. How do you deal with adverse weather, night and fog? Do you need to dynamically replan? What are the regulatory issues, right? Especially as drones are being regulated more and more, increasingly more and more. And how about social awareness? You want people to be able to accept it. You don't want people taking pot shots at it. What about privacy concerns? What about liability? What about insurance for any kind of thing that may happen, right? So my point is that there are a lot of things that we had to discuss, and these are all evolving as we speak. Okay, these are not by no means solved problems, but it's something that we have to be aware of. So let me just address a couple of technical issues, because this is the robotics forum, and then we'll move back into what we have done so far. So as as I'm sure all of you know, what an autonomous system is: it sets its own goals, perceives its own surroundings, build an internal map, adapt to unanticipated events, and acquire and apply knowledge and skills, and successfully interact and collaborate with human operators. Of course, this is really a soft definition. This is what we mean by autonomy, but and there are many different definitions of levels of autonomy. If you look at OSD definition from their roadmap, there are like 10 levels of autonomy, and it's most of our current technology is at level 3, and not quite at level 3, but you might say it's somewhere there. Certainly we are not level 4. So the question is, what level of autonomy do we need to be able to implement this, right? That's the question. So we think it should be between level 3 and 4 for you to be able to implement this. Um, and of course, you have so this is something we are working through right now. We have all the typical system architecture. You have a sensor layer, perception layer, guidance and navigation. You have an allocation layer, and you have a typical vehicle layer. You have a global level issues, and you have user interface, right? So this is and I took this out of one of our other projects for some of the work we are doing with unmanned surface vehicles. But this is typical with all unmanned robotic systems, right? So we're working through all this, and like I said, we are more advanced in some of these, and we are not so in some areas. So again, the typical design issues here are thrust, lift. We have to design this power, endurance, mechanical, electrical, flight controls, algorithms, obstacle avoidance, which is for in this case we have to be. It's a congested atmosphere, a congested environment. You're flying at a fairly low altitude, and you're potentially have buildings coming up there. Certainly you have utility wires and such, and of course birds and other moving objects. Although cities like Bengaluru, they've with the rapid development and congestion and increased traffic, they've managed to get rid of birds, most of them. So I think we are lucky with that respect. There are nuisance issues, noise pollution. Do you have to worry about that? Although it's less of an issue right now currently in urban India, and maintenance, long-term reliability, and all the other issues. So you have, what is we need to be robust. We don't want this to have a lot of communication dropouts. What's the sensor noise effect, model and parametric uncertainty. We have disturbances, storms, and so on. Dust, heat, smoke, which is always an issue. You have interference due to magnetic and EMI and so on. You need to worry about some kind of self-diagnostics. It can crash in the middle of a crowd, for example. What do you do with that? Of course, it can be stolen, like I said. All right. So there are a lot of issues that we are working through, as you might imagine. And I just want to talk about some of the things we've been able to do. And please keep in mind that this is work in progress. Let me just take a look at the time. Okay. So what is the current status? So in working with with the ambulatory services, working with the hospitals, we have set a cruise speed requirement that we need to be able to we need to be able to, we need to be able to reach the accident site up to 15 kilometers. So that's our radius right now, in 8 minutes. And the 8 minutes we divided into 1 minute. It should be able to after receiving the distress call, it should be prepped and ready to go within a minute. It should time to locate and drop the package. After reaching the approximate location is about another minute. It's got to hover, and and I'll talk about how we are doing that. And the time to cruise is about 6 minutes. So this means it needs to go about 150 kilometers per hour at the mean sea level. Note that the range and those things are affected by the altitude as well, right, above the sea level. So an example payload is what we call an ABC kit, right? ABC is basically bleeding control, right? This is the project they already have, and I'll talk about that project. Nothing to do with UAVs. They've already had a project where they've been training people, and this is the kit they like to use, which has sort of it's an active bleeding control kit. So it's got bandages, got tourniquets, it's got or ability to make a tourniquet out of bamboo sticks, and dressing pads and so on. Very, very simple stuff, right? But it kind of is, it's packaged, and that's our payload that the UAV needs to carry. Now, if it is a CPR kind of related, it's a cardiac arrest kind of a situation, then you have to carry a defibrillator, and maybe instructions and so on. So right now we are focusing on the ABC kits, and it's about a half a kg, so dispensable or disposable. And there are other questions that come up. For example, what if there are multiple accident victims? Is one kit enough? It's not going to be enough. It's a car accident. There are 4 people in the car. 2 people get injured. What do we do? Do we need to carry more? So right now, these are future things. We're just thinking about it. Right now, the maximum altitude of takeoff based on the aerodynamic considerations is 2,000 meters above the sea level. Bengaluru is about, I believe, is about 1,500 or something of the sort. So so in that we kind of set it to that height. UAV will be sized to complete 50 kilometers within 8 minutes, like I mentioned, and it will be lower at lower altitude simply because of the aerodynamic considerations. Um, so there are questions. For example, are there situations where takeoff and drop off altitudes are dissimilar? In a like in a hill station, like in a very hilly area, what they call hill stations in India. Um, and we want to do like a demo mission, take off and drop at the same altitude, and we will decide based on the recommendations of the DGCA, is the Indian Department of I think it's General Civil Aviation. So they I think they take the role of FAA inside India for Indian flights. So these are the specifications we are now adhering to. This is what our system is. It's half a kg, like I said, a payload. It's a downward facing landing camera. So the camera is primarily there to control the final drop off and kind of get the situational awareness. There's a control system is a customized ground control system. GA is General Aeronautics, which is the company which is doing this. Working temperature is about 10 to 55 degrees. That's not minus 10, I don't think. I think it's plus 10 to 55 degrees Celsius. Flight altitude, like I already mentioned, there's a communication range is about, in phase 1 is 5 kilometers, phase 2 is 15 kilometers, flight range is about 15, like I said. The maximum flight time for this vehicle based on the power source is 60 minutes, and it's a cruise speed of about 100 kilometers per hour, wind resistance of 12 meters per second. So we kind of went through in phase 1 and phase 2. We are in phase 2 right now. We should be able to withstand up to 12 meters per second wind resistance. So this is the drone that's been developed, and we have a couple of different kinds of prototypes, and that's just a picture of the happy people just before a test flight. Okay, so I'm sorry, I have a typo here. What I meant to say is technology is only a part of the solution, right? So let's talk about other things. So how do you do this? Well, like I said, they already have what they call ABC project, or active bleeding control, what they call INSPIRE. So there are already programs in place, primarily led by Dr. Nadkarni, my collaborator at Children's Hospital, as well as Dr. Ramana Rao in India, where they have sort of what they call a curriculum. They train the people and they train the trainers, and then they get them out and to train more people. They've so what we've done is we kind of put them all together, right? We are connecting with that, and we're building the interface with that, because this is not something we can kind of do from scratch. So they kind of already have that. Now the question is, can we develop the UAV system to work with the system they have? And earlier they would just maybe use bicycles or something and get them there, right? But the idea is to use UAVs, which would be a lot better, a lot more efficient, and a lot more effective. And then, there are other things we're doing. For example, the training programs, we are kind of doing the testing. We're getting the right permissions to do this in urban areas. We're collecting the data from bystanders to find out, what's going on, right? And who are the people that you can train? Well, people like these drivers, right? Auto rickshaw drivers, people who drive this. And, typically they are probably didn't go past middle school. But they're smart people, but they just didn't, they're entrepreneurs. They have this, they drive these little taxis, and they're very well intentioned. They want to save people, but and they're very, very willing volunteers for this. They're volunteers, they're not being paid, right? And the bottom figure shows them, sort of learning how to do this, right? With part of their the workshop. And of course, police, right? Police are everywhere in India. India is one of the largest police forces in the world. Again, they're well intentioned. They want to do things. They're very professional, and this is part of the training mechanism. And then of course, how do you train them? Well, you cannot do this in English. About 35 to 40% of India has the largest number of English speakers in the world, but still there's only 35 or 40% of India who speaks English, or maybe less than that. So, and a lot of these people necessarily are not that fluent in it. So you got to train them in multiple languages. India has about 1,000 languages and about 3,000 dialects. And something like 28 scripts or something of that sort. So you need to at least develop material, education material in multiple languages to make sure you reach everybody. And in this case, this was done in Hyderabad, where the predominant local language is a language called Telugu. So they're kind of explaining how to do this and develop the thing. And then there is all these other kinds of stuff. For example, you recognize them and you reward them, right? So they've developed an ID card, a volunteer sticker, all kinds of things. So it's easy to also to identify them. To date, I think more than 1,000 volunteers have been trained, and you can see auto rickshaw drivers, police, students, shopkeepers, little shopkeepers, toll plaza employees, bus drivers. People are just other volunteers who may be willing to do that, right? And this is sort of a demonstration of a case scenario. They're kind of doing, demonstrating this on a mannequin, right? Like pulling them out from under a bus. For example, somebody run over a bus. What do you do, right? And then all the way up to the ambulance coming and picking them up. So look at the time here. Okay, so like I said already, I think I already talked about this. So this is sort of the way we are working through. We're collaborating with the many of the stakeholders, training the trainers, and their and earlier last year we launched it, and this year took a hit because of COVID. But it's getting there. So this is phase 2, like I mentioned, and what we're doing, for example, we have already developed this ability to use a drone to drop the kit, and then there is a telephonic advice. There's there's a technology issue. Basically, you got to send a text or some kind of alert out to anybody who's close by who can get there, and then they had to be able to receive the UAV and the kit. And this is a part of the near Hyderabad in Andhra Pradesh in India, where we kind of sketched out an area where we'd actually do this, where there's accidents and you'd get there. Like I said, this is kind of what's been done. And let me see if I can maybe, yeah. And there is a lot of you can see a lot of activity around this, right? Again, all of this really helps motivate the people, get the people behind you, right? And the media is kind of bought into this. This Hindu is a prominent national newspaper, English language newspaper, and so they have publicized this as well. And you provide awareness in media, in the public conferences, and then you recognize and you celebrate the volunteers, right? You reward them in some, if nothing else, recognition. And all of this is very good. And then, of course, you need to collect data to find out, what are the barriers? Why didn't it work? What worked? How long did it take? What are the issues? What is the reception of the UAVs? You have to do this, and this has to come back, eventually make its way back to the technical design, right? That is, the users have to become a part of this feedback loop in your, primarily in the design loop, right? Okay. I'll mention, I'm getting close, so let me just try to finish this up. Okay, so this has been a very interesting project, and I want to say we are still we haven't made as much progress as we want to make because we haven't received large amounts of funding that we would need to make this like a full reality, right? And we're still working on it, and hopefully we'll get there. But my personal vision for this would go beyond what we're doing, right? So, for example, what if we integrated diagnostics, which is very possible because we are now able to do more and more diagnostics to provide decision support on the road to the bystander, for example, right? Because again, this could be way far out in the future, but I think that would be my vision, right? You may be able to do, for example, face recognition and infer what the problems are with the patient. There's no real reason why we couldn't roboticize or actuate the devices themselves, such as CPR, which would or maybe semi-assist the bystander, so it makes it a little easier for them to do something to increase its effectiveness. It's possible that you could use UAVs to just issue alerts, and right now the companies actually adapted some of these drones for COVID. For example, to alert people that they're getting too close to each other, to enforce social distancing, things like that. So, but you could do more than that. It could also be potentially useful in a disaster situation, or in a situation that would, God forbid, if you have a bomb explosion or something like that, terrorist situation. Obviously there's more stuff that the same drones could be used to do. Information collection needs to be we need to think about how to do this. That is the patient data, and some kind of integrated into some kind of an adaptive process development of how to do this, right? We are very far from this, I should say, and ultimately we should not forget that UAV is really a mobile and a controllable sensor and a node, and lots of things are possible. For example, we are talking about fleets of drones doing things rather than a single one. You could have one, for example, that just carries a high resolution video that gets there a little later, perhaps, but just able to coach them and has a two-way interface with the doctor, for example, right? And that could be connected back to the ambulance that's making its way there, for example, right? So I think there are it's really exciting, and I think there are many ways to go. And obviously, something I didn't really address in detail is there are a lot of technical issues. I didn't even address the issue of you know how do you navigate? I mean, what is the safety envelope for something like this in an urban environment, which is very dense, with people, with vehicles? What is our tolerance level for safe failure? If you have a UAV falling on the road on top of a car, what happens then? And what is the probability of what is the eventual effect of a UAV or a drone carrying an ABC kit not getting to the accident victim when they're expecting it? Then what happens? So that should you have backup system? Should you have, we don't know, right? I mean, there are a lot of, I would say, control autonomy issues that have to be solved to, we can certainly write out the mathematics and do it, but it's going to be a longer haul, right, to do this. Of course, there is some, work that's being done already, but we see a gap, and we weren't willing to wait for this gap to be filled before kind of going ahead with this technology, right? So that's kind of what we're doing. So obviously, even this amount of work required a lot of support. The support that for the workshop primarily came from IUSSTF. Penn Global has stepped in with some support to especially for some of this training and to fund some of the UAV development. The GVK MRI has kind of put out, that's the ambulance services. They've put out a lot of their own efforts to support this. Villanova College of Engineering has supported us in kind and in to some extent my time to a large extent my time to do this. And Children's Hospital of Philadelphia has been also supported some with both funds as well as Dr. Nadkarni's time. Okay, so we really appreciate this, and we are still looking. So if there happens to be a funding agency watching this, we will we really welcome your input to see how we can make this really a viable project. Like I mentioned, potentially we could have as many as 50 to 60 people working, either supported or voluntarily, volunteering to work on this project from many different institutions, covering all different aspects of the problem, from technical to medical to legal to regulatory. I would like to thank IROS Conference Committee and Dr. Garrett Layton for this extraordinary opportunity to share my thoughts on this and my enthusiasm, excitement. I hope my excitement came through. To all my collaborators and students, obviously that's I'm just speaking for this large group of people. I'd like to thank you all, assuming you didn't fall asleep yet. Feel free to contact me at nataraj@villanova.edu, or you can check out our website at vcats.org. And finally, I would like to say that I don't do anything. I'm just a mouthpiece. This is my student group as of last summer. They were. I promised them they would get a bonus if they smiled for the photo, so they all did. Thank you. Look forward to questions and interactions on whenever the panel session is held.